Hi everybody, it's Oskar Świerat here. In this video, I'm going to show you how you can add a decent amount of randomization to a highly modular building. What you can see here is a building that has a varying amount of damage between floors, random color palettes for items, and even certain items are hidden on some floors while visible on the others, like the air conditioners. On the bottom we have a layer of dirt, which is not visible on the upper floors. The entire building is made of this single module, being copied with blueprints completely automatically. Here I only specify the number of floors and the number of segments, and all the randomization is done within one material. There is only one material used for the entire building, except for the windows, so everything happens within this single material. Let me show you an additional feature of this shader, which is choosing the color of the paint, both secondary paint and the primary paint color. And as you can see, the damage isn't affected by these changes. So how is it all done? The first trick is how I made the base color texture. It has a transparent background and there are two sets of textures. So the first one is clean and the second one is damaged. The clean and the damaged texture. And the additional thing I needed here is the vertex color. Basically, my vertex color is used for masking the certain features. The red vertex color channel gives me the mask between the primary and the secondary color of the background. The green channel was used for randomizing the color of the secondary items. So as you can see, here we have a yellow cloth, while here we have a teal cloth. And the blue vertex color channel is used for randomizing, or rather for adjusting the offset in the x-axis. So the darker the color, the less the object will move on the x-axis. It's controlled by this parameter in the shader. And there is another thing that was very important for this shader. It is the random number that is generated or calculated for each segment and each floor, each individual mesh. And the single random number that I generate allows me to randomize all these features so they are not identical from floor to floor. Even the hiding threshold is varied, as you can see. It's not only the threshold of the blue channel, it's also the additional random number mixed in. So before I go into the details of the shader and the blueprint, let me show you how you can easily create the vertex color using the software called Houdini. You may be interested in Houdini because lately there was a great Unreal Engine stream about it with the stuff from Side Effects, the creators of the software. Houdini is basically a full 3D creation suite. It's a full package, but its workflow is entirely node-based. Every operation is a node, but it's really an artist tool. And I will do an entire big tutorial, a course on Houdini in the next month, but now let me show you how you can create the vertex color in this for our needs. First I begin with a color node, set primitives here, set the color to black. Okay. Now I want the red color only on the walls. But as you can see, the number of polygons here is quite high for manual selection. So instead, I enable group selection and I will select by UV islands. Here all the islands are designated for me. I choose this one, and the middle ones. Okay, great. Now my vertex color is bleeding to another wall because they are connected, the vertices. So I can change the class to primitive and is perfectly sharp. Now, for the green channel, I take the node that's called attribute randomize. There is really a ton of nodes like that. Houdini is an artist tool. You can write scripts, you can write code, and you will in the advanced later stages. But the nodes are really useful. So here primitives again. And as you can see, it shows a random color for every primitive. That's not exactly what we want. The first thing is that we want only to modify the secondary items. Okay, great. Only these things are randomized. Now I want it to choose a random value for the entire submesh. But this object is only a single mesh. It's not separated into objects here. I merged it all to export it to Unreal. It's completely not a problem for Houdini. I just need a connectivity sub. Sub is a name for node. Attribute class. Basically, everything in Houdini is an attribute. So here you can see the attribute for position that is written into points, and this is the attribute for each primitive, that is each polygon. We can rename it to submesh. And here we have an attribute that is created by us. It's not a fixed set of attributes like in other software. So here we go to options, choose a seed attribute, submesh, and we have random values. Now we don't want it to override the red channel and only select the green channel. So what I will do is write the maximum value of red 0, blue 0, green remains 0 to 1. Instead of set value, I will choose add value. I want to repeat the same functionality for the blue channel, but in a different section of objects. I want only this thing to move. Now it's randomly choosing the values between 0 and 1. Maybe it should be between 0.1 and 0.5. Perfect. And as you can see, instead of replacing these values, it's adding the value. And that's it. We are done. Now let's go back to Unreal and I will show you the blueprint part of this. So basically how to create an object like that with the control of number of floors and number of segments. First we need to go to the content browser and create a blueprint. The actor type would be OK. It's the basic type of blueprint. Then you have to drag it onto the level. Basically a blueprint, it's a template of the object. So we can create many instances of a single blueprint. Now this is the one I created. And we edit it here with edit blueprint or with the shortcut Ctrl-E. Blueprint is both the name of the basic type of object in Unreal, but it's also the name of the visual scripting language that the behavior of the object is driven by. And there's a special kind of graph in every object that is called construction script. The execution flow starts here, and if I start to type static mesh, then I have the suggestion of add static mesh component. That's what I want to do. It basically adds a static mesh into this object because an object can consist of multiple meshes, and that's what we need. As you can see, this is our object. Here I can specify a relative transformation by make transform that is suggested here below, but I don't want to manually add every mesh. I want it done by a loop, an automatic loop. Here on the left, in the My Blueprint panel, you can add your own custom variables. So my first variable would be number of floors. On the right, in the Details tab, we change the type to integer, which is a whole number, and make it editable. Then it will show up in the viewport also, not only here in the editor. So basically the user can edit this value. And for my convenience, I can create a variable of type static mesh. For example, my wall module. Now when I have these two variables, I make a for loop. First index will be 0, then the last index will be the number of floors, get. Now type in minus symbol, integer minus integer, -1. So the first module will be numbered as 0, the last one will be number of floors -1. Okay, and for each floor, I want to create a specific amount of segments. And in the loop body, which is what happens in every iteration of the loop, I create another loop, number of segments -1. And in the loop body, I will add a static mesh component. Let's make some transformation for it. And what I need to do, what's very important, and you can miss it easily, is that this node in its details tab have a mobility setting here. By default is movable. It is a building that I want to light with static lighting, GI and so on. So I set this to static. There is a lot of other options too, typical to static meshes. They are all okay by default for me. Now what should be the transformation of every module? Basically, the number of the current floor multiplied by the height of the module will give us the location in the vertical axis, while the number of the current segment times the width of the module will give us the x-axis location. So fortunately, here we have the index of the current iteration of the loop, 0, 1, 2, and so on. I will multiply it by a float number. Now I drag my mesh here, basically reading this variable, and I can get its bounds. Now what I have here is a complete object that contains the bounds, the boundaries of the objects, but I can break it, and then I get box extends. Extends here mean the half of the width, height, and so on. So it's a half of each dimension of the object. So I can break it further into XYZ. Now to make the location, I can click split struct pin here. I have location XYZ. I take it and it will be my Z location. Compile. Something doesn't work and I have to check why. Okay, what I forgot is to set the template that will be used to create the static mesh. So I take the newly created static mesh, set static mesh here, and here I take my variable here, and it works fine. Here we specify the number of segments, here we can change the number of floors. When we go back to the viewport, we can still access the values here in the details tab. So the number of floors and the number of segments. And that's basically how I created this one. Let's see the inner workings of the shader. So this is our material. Here I mix the two sets of textures and set the underlying color, which is the color of paint. The damage is mixed in using the cell noise that I painted myself in a 2D software. I packed two noises into a single texture to save on space and on video RAM, video memory. When you are doing such packing And basically for all kinds of masks like roughness, albedo, which is base color, and so on, you have to set the compression settings to masks here. The same packing is applied to metalness, roughness, and occlusion, which all are packed into a single texture. Red is metalness, green is roughness, and blue is occlusion. In the DXT compression, the green channel has more information, more bits than the red and the blue channel. So basically, this channel preserves more details than the other channels, and when you can avoid alpha, like I do here, then the size of the resulting image is really lower, because it can then use a different compression technique that doesn't require alpha. So it's much lower than just the 25% that intuitively the alpha should save. So I recommend using the textures of free channels with no transparency unless you need it. As I said before, my base color has the alpha channel, so I can use any color as the background and have the damage being drawn on top of it. Here's the mixing of the textures. So linear interpolate node, the shortcut is L and click, or right click and verb, linear interpolate. It mixes between two textures or two colors, with the alpha being used as the factor of the mixing. It's called alpha, but it's just a factor, a scalar number. And what's returned from this white pin on the texture node is a vector of 3. It doesn't contain the alpha, which is given here as a separate value. So first I have to mix between the base colors, and then I have to mix between alphas. Later I will mix between these colors and the final texture, using the alpha channel as the factor for the linear interpolation. It's how you do mixing textures on top of each other with transparency. You use the transparency as the alpha for linear interpolation. So this is the background, and the mix of these two base colors here is the foreground, with alpha being the factor. Then after I mix the combined metalness, roughness, and occlusion, I can split it into separate channels. Before I'm finished with this, I apply some dirt to base color. To create the mask that is used to apply this dirt, I create a linear gradient from the lower part of the building up to a certain specified height. So here I have height minimum, height maximum, and this is my own material function. It's a remap node. Basically it's used like that. It takes a value, z value of the world position of the vertex, which is the height of the vertex, and it takes the range that the value is within. And what I want to have as a result is the same value being fit between the range of 0 and 1. So I really have a gradient which I can use later for mixing. It's also called normalization, and it works like that. So it's a really simple function, it's really easy to calculate, not a heavy function, and it's extremely useful everywhere where you have to deal with distances, different ranges, even adding contrast with this simple function. Then I use the quite new function in Unreal, which is called noise, to add some detail to the basic linear gradient. You give a vector of 3, called here a position, and really it can be a position multiplied by some value of frequency of the resulting noise. It's like the scale of the noise, the multiplication of the position, and what you get in return is a value for example between -1 and 1, or it can be between 0 and 1, or whatever, a random value, but not completely random, not a white noise. Instead, you can here choose the function that is used to compute the noise, and the noises are unfortunately very heavy. They add tons of instructions to the shader, so please make sure to choose the noise that is most lightweight and still okay for your needs. In my case, it's the fast gradient. It's really the most simple, most ugly, okay, but most simple function of noise here to choose. So fast gradient is enough. Now the levels also affect performance. So for example, if 2 is okay, choose 2. Only then look how it looks like and add more. That's where I get my mask. I take it to a power of 2 to add some additional darkness and contrast. And again use linear interpolation for that. Now let's see this part of the shader. This is a very useful thing I told about some time before. It's again a noise function here, but this time not taken from the vertex position but from the object position. So what I want to have is a random number between 0 and 1 for every separate object. If you were doing instancing instead of static meshes, then you have then access for the node that's called per instance random. And you can use this per instance random instead of the noise here. It's automatically generated for every separate instance, allowing for some nice randomization of them. I created this material in such fashion that you perfectly can use instancing with it. So instead of static meshes, you can use instancing, like hierarchical instance static meshes, which I made a video about before. And then you have huge savings in terms of performance. It really saves a lot of video RAM, a lot of runtime performance, but then you won't be able to use static lighting. Only dynamic lighting will be possible. So really it's up to you. If you can deal with not having static lighting, then instancing is really a way to go here with a project like that. Now what I use this for? I modulate the green and blue channels of the vertex color by this random number, here by adding it, and here by multiplying it. What I have here is picking a random color for each item. So I take this value made of vertex color and this per object random value and use it as the U channel in my UVs for this texture. So basically the horizontal axis is driven by this value, while the vertical axis is set explicitly to half. And the color palette tiling is like the frequency of this palette. So we have more randomization within the vertex colors 0-1 range. By default I will set it to 3. What I do here is creating a mask for this change of the color, because I only want to change the color of the items, not the walls, not the dryers, windows and so on. So if the value, it's again the remap function, if the value is lower than 0.01, it will be black, while when it's higher than 0.015, it will be white. Kind of a threshold for it. And then I use linear interpolation to mix in the resulting color from the palette. Now here I hide certain items. So I take the blue from the vertex color, and here it's the same feature like above, the masking feature, but done differently to show you the possibilities. I subtract 0.01 from the vertex color, So basically, values that are 0.01 or lower than this, really small or black values, will end up being below 0 or 0, while everything higher will remain above 0. So by subtracting this small number and then using the ceil function, the ceiling, I round the value to the nearest integer, the nearest higher integer. So the ceiling, when it encounters something below 0, will return 0, black, while in another case it will return 1, so full white. Then I multiplied what I got by the blue vertex color plus this random number from the object position. And by doing this, I receive the final value, which I use to control whether I should show or hide this object. Here I have a hiding threshold parameter. If the new value is above the threshold, I choose to hide the item. It will be 0 in the opacity mask, and otherwise I'll decide to keep the item, so 1 in the opacity mask. And the blend mode of the material is set to masked. It's like translucent, but without all the heaviness of translucency. It only allows for having either 0 or 1, as I explained in my tutorial about the opacity in Unreal Engine. So mask is very lightweight, it's almost the cost of a normal regular solid mesh, and then I output either 0 or 1 to opacity mask here. Now the final feature is moving the items in the x-axis randomly. So again, I take the blue channel of the vertex color, or I take this random number, and first thing I want to do is to take the number which is between 0 and 1 and make it between -half and half. So scaling it, multiplying it, will always be done from the center of 0. Then I multiply it just for convenience by 100 and multiply the resulting value by the position offset strength. Now it's only the value on the x-axis, while we need a full vector of 3 to move the final position offset. So the append node will first take the scalar number, a single number, and add a 0 to it as a second component. The append node adds another component to the value, making it a vector of 2, and from a vector of 2 making a vector of 3. Here I take the local position of the vertex. As you can see, it's a simple function. It's up to you whether to use it. It's quite simple. And I add this offset to this local position. Now what we have to finally give to the engine is unfortunately the world position offset. So it's an offset in world coordinates, not local coordinates. It's not even the final value, it's just the offset. So how do we convert it? I first add this offset to my local position, having a local position that is moved. Then I transformed this moved local position into world space, and I subtract the original world position of the vertex from this new world position of the vertex, basically having an world offset in return. Then I provide it to this world position offset, and that's it. So this is our entire shader, and as always you can download it from my Gumroad page. There is the whole project containing all the tutorials made so far. Of course, should you have any questions regarding this project, please ask in the comments, and if you have time and possibilities, if you know the answer, then help the others. I hope this thing was useful to you. I tried to show a lot of features contained in a single project, and I have to say that I'm sure that you will make a much better material out of it, taking my project just as a start it was a very nice surprise when ZeoYuri78 took my tutorial and created his own optimization of it. So basically what I said was impossible now was proved to be perfectly possible in Unreal. So yeah, thank you very much for watching. Good luck with your own projects and using it in your own stuff. And see you next time. Cheers!